INFN, the National Institute for Nuclear Physics, is the Italian public research institute dedicated to the study of the fundamental constituents of matter and their interactions. INFN is a community of over 6,000 people. They are committed to both theoretical and experimental research in various fields, such as subnuclear physics, nuclear physics, astro-particle physics, as well as technological research. These research activities are undertaken in collaboration with Italian universities and with international research institutes such as CERN. CERN, is the biggest, the largest particle physics laboratory in the world, hosting the most powerful particle accelerator ever built, the Large Hadron Collider, LHC. So that really is big science, and big science means big data. Actually, modern scientific experiments produce a huge amount of data that need to be stored, preserved, and accessed by communities of researchers which are distributed all around the world. CNAF is the main data processing and computing technology research center of INFN. It is located in Bologna. Data produced by the various experiments in which INFN is involved are stored here at CNAF, and they are made available to researchers for their analysis.
The total amount of disk-based storage installed at CNAF is about 50 petabytes. Most of the scientific data we have, and we are talking about 100 petabytes of data, are reside on tapes like this. Each cartridge has about 1100 meters of magnetic tape, and we have about 12,000 cartridges like this.
I work in ELIS, one of the 4 major LEC experiments at CERN. ELIS is devoted to the study of matter in extreme conditions of temperature and energy density. Similar conditions were realized about 1 microsecond after the Big Bang. When energy density and temperature are so high, it is possible to study the properties of matter and strong interaction. As all LEC experiments, we are using intensively CNAF resources to perform data reconstruction, analysis and simulation.
Tape technology is crucial for the computing model of the experiments in which INFN is involved. Raw data are typically stored on tape in order to keep an archive of information about events that might not be reproduced in the future. Here at CNAF, we have to ensure data protection over time. Moreover, we are asked to provide high-performance systems in terms of data throughput, latency and accessibility, and of course to minimize the overall cost. During the run 3 of the LAC experiment at CERN, we are expected to supply up to 4 GB per second as writing throughput to tape and a similar rate for reading from tape. At the same time, we need to satisfy the requirements of more than 30 other experiments that have data on tape at CNAF. Systems are often used at the limits of their possibilities, and we have to find the right configuration and design software solution in order to reach these limits. Science becomes more and more data intensive, and we need to keep up with it.
So, new challenges await CNAF in the next few years. Soon, our data center will move to the Technopole together with other national and international scientific institutes. The Technopole in Bologna will be the main Italian computing center, one of the biggest in the world, hosting around 80% of the national computing power. A new location where CNAF will grow and will be ready to face the new challenges and new demands posed by science.